Okay, let's take the first question. Let's say that this expression is the zeros. Well, if x minus 3 is 0, the whole thing's 0, right? Called the zero property multiplication. Any product of numbers, if one of those numbers is 0, you're going to get 0. So if this is 0, if this is 0, if this is 0, you're going to get 0. Well, x minus 3 equals 0 has a simple solution. 2x plus 6, well, that gives you x equals negative 3. And x plus 8 gives you x equals negative 8. So you have zeros. We can actually go ahead and put them on the graph. And take what this means. Okay. X equals negative 8, we'll put that here. And there's a 0. X equals negative 3. Well, let's see, that would be negative 4, that would be negative 2, that would be negative 3, that would be here. And x equals 3, well, that would be an equal distance from this side, right? So the zeros are, well, at these points. Okay, Y-intercept. No, I skip the step writing 0 minus 3, 2 times 0 plus 6, 0 plus 8, because we know 0 minus 3 is going to give us negative 3. 2 times 0 plus 6 is going to give us 6, and 0 plus 8 is going to give us 8. Although it doesn't hurt to write that stuff out, especially the first assignment you do with this stuff. So that's going to be negative 18 times 8, which is negative 144. So I'm going to put it right here. And now, how do you draw a graph through these points? Well, the graph should look like this. Okay, well, let's look at some alternatives. Okay, graph might look like this. That's a reasonable approximation of what this might look like, right? Or it might look like this. It won't at this function, but right now you don't see any reason why it wouldn't. That'd be perfectly okay. Except there are several good reasons why it wouldn't. Or the graph maybe it could look like this. Okay. Now, only one of these graphs makes any sense, but you have to see why. All the graphs go through, well, actually, this graph doesn't go through the Y-intercept, right? So I could do another one, illustrate what I really wanted to say. A nice smooth graph goes through all these points. Could be a different color. That one. Okay. Okay, that might work. Except it won't. Because first place, the reason this can't work is it's not a zero there. This function is not equal to zero unless one of these is equal to zero. The other part of the zero theorem is, for the zero property is, if at least one of them isn't zero, then the product isn't zero. You multiply a bunch of numbers that aren't zero, you're not going to get zero. And the only way any one of these could be zero is if this one's zero, or this one's zero, or this one's zero. So here are the three zeros, and that's it. No other zeros. Okay. So this can't be a zero. So the graph can't go through this point. Now it goes through all the other points, but it can't go through that. Okay, up here. Well, let's look at the long run behavior, because some of these graphs violate the long run behavior, including this one. Matter of fact, all of them, except the first one I drew, violate the long run behavior. A huge positive x applies at x minus 3 and 2x plus 6 and x plus 8 are all huge positive numbers. So their product and use a word that's not really a word, is a humongous. Positive number. And meaning that the graph has to go up rapidly after you pass this point. Can't go through zero again. It's got to go huge. Okay? It's got to be positive. Well, on this side, a huge negative number makes all these negative, doesn't it? So you got a product of three huge negative numbers, which is negative in homologous. Okay? So I don't have a good place to write this. Huge negative x implies a humongous negative y value. Okay. That's written pretty small. If you sit in the back, you might not be able to read that, especially if handwriting wasn't very good here and here. But all we're saying is this is the long run behavior. This is exactly what the book told you, isn't it? Except your book said it's x approaches infinity instead of a huge positive number, right? Well, it's important to think of x approaching infinity, but it's a step in that direction to think of what if x is a huger positive number, because that means it's approaching infinity. Okay? So huge positive numbers give you huger and huger, humongouser and humongouser, more and more humongous y values. Huge negative numbers give you huger and huger, humongouser and humongouser negative y values. And you need to understand that. Of course, you need to understand numbers well enough to understand that, but I think you do. which means that the graph goes down here. Now, it can only go through the zero, it can only go through the x-axis at these points. And it can only go through the y-axis at this point, because on the y-axis, x is 0, and that tells you that you're at this point, right? So your graph is going to look like this. And I still do the wrong. Okay, that's a badly drawn graph. The point I want to make is the y-axis is not the low point unless it is. Okay? And very seldom will the y-axis be your lowest point. You draw the thing so it goes through the points, and you don't try to make this the lowest point. I would actually make it a little shallower here, and maybe the low point even be on this side. Okay, and I mentioned in the previous class, the support class, if you know calculus, it's really pretty easy to find the high point and the low point for any cubic polynomial. You just end up having to find the zeros of a quadratic polynomial, which you do by the quadratic formula, and then you've got it. Okay, anyhow, that's what the graph of this thing looks like. Okay. The zeros of this one. And I only asked you to graph it first, so I'm just going to do the zeros here. Okay, well, I'm going to write down. Okay. So that's the one I'm going to do. Zeros occur when plus 3 equals 0. 3x minus 18 equals 0. X squared plus 14 equals 0. Okay, well, solve this, you get x equals -3. 3x minus 18 equals 0. Well, add 18 to both sides, divide by 3, you get x equals 6. And x squared plus 14 can't be 0, because x squared can't be negative, right? Right, you could say, so x squared is -14, right? So this doesn't give you 0. Then the y-intercept. Again, when x equals 0, you're going to get 3 times -18 times 14, right? So and I know you're going to have to multiply that out. That's 180, 72, 252, 3 times that is 756. I think that's -756. What about the long run behavior? Well, it should be clear that all these are positive when x is positive, right? And they're all big when X is big, so you multiply a bunch of big numbers. So you're going to have a big positive, right? So I'm going to just write it the way you both does. As X goes to infinity, Y goes to infinity. So what happens as X goes to negative infinity? Well, this is going to be negative, isn't it? X is a big negative number, so is X plus 3. If X is a big negative number, 3X is even bigger, and 18 doesn't make any difference. So this is negative. What about X squared plus 14? Is it positive or negative? Tell me positive or negative. X is a big positive, a big negative number. If some are saying positive, some are saying negative. And some of you are making rude gestures. So what happens? Well, you're squaring X, right? You square a negative number, you get a positive number. If remember, you square is a big negative number, square is a really big positive number, right? So you would have positive, positive, positive. So I'll write it this way. This approaches negative infinity, this approaches negative infinity, this approaches positive infinity, right? So the product approaches negative times positive infinity. Okay, using the little. So this all has to be positive infinity. So that means it goes up as you go to the right, and it goes up as you go to the left. Let's see how the graph of this thing turns out. Well, actually, let me ask you to take this information and sketch the graph. Okay, now a number of people are drawing a graph with 3 zeros when it goes like this. But there aren't 3 zeros. X equals negative 3 is a 0, X equals 6 is a 0, and X squared plus 14 can't be 0. X squared plus 14 doesn't give you 0. X squared plus 14 means X squared equals negative 14, and there's nothing you can square to give you negative 14, right? So if you plug whatever that third 0 is in to the function, you're not going to get 0. Okay, try it. Think X equals 14, plug 14 in. That's not 0, that's not 0. 14 squared plus 14 sure is 0, right? Okay, so what's the graph look like? Okay, well, these zeros are negative 3, 6. The Y-intercept is at 0, negative 756 if I did my mental arithmetic correctly. Okay. So what does the graph look like? Well, also, X goes to infinity that way and this way. So that's right. As X goes to infinity, Y goes to infinity, and that's kind of this way. As x goes to negative infinity, y goes to plus infinity. You have to have a graph that comes down here, goes through this point, and comes up here. Excuse me. Let's answer a question. Pause. Okay, so we have a question. Somebody said, isn't that x plus 3 supposed to be squared? Well, yeah, there's a square there. I didn't write it down, did I? Well, that's going to change something. We'll see how that changes. I didn't do this on purpose, but it'll work. So right now, I'm talking about this, not a function that is actually written down. Okay, so, well, you know, this thing could look a lot like a parabola. You might as well draw it looking like a parabola. But if it's skewed one way or another, a little lopsided, that's actually what's going to happen. Okay, but you wouldn't know. You wouldn't know. So as long as you go through these 3 points and get up to plus infinity in both ends, it's okay. Well, now let's try. Try this again. Okay, now I've got the square here, right? So what changes? They're the same zeros as before, right? Because x plus 3 squared is 0 and x equals negative 3. And only when x equals negative 3. As x goes to negative infinity, x plus 3 squared is now positive, right? And 3x minus 18 is negative. And x squared plus 14 is positive, right? So y is a product of a big, huge positive number, a huge negative number, and a huge positive number, right? Which is going to be positive or negative? Tell me. Positive or negative? Negative, right? Because you got a negative times 2 positives. Y is going to be a huge negative. That is y approaches negative infinity. So now you have a graph with the same zeros as before. Oh, and the other thing is the y-intercept is now going to be 2268. Okay. Also, y-intercept three squared times negative 18 times 14, which equals positive 2268. Again, if my arithmetic is correct, which it might be. I think I have a good chance that I got that one right. Okay, so now we have 0 at negative 3 and a 0 at plus 6. And the y-intercept up here 0, 2268. Got to go down here, and it's got to go up here. Now, how are we going to make that happen? If we come up here and go through this point, come down here and go through this point, we can't get back up because we can't go through the x-axis except at the zeros. We can't add zeros. The zeros are exactly what they are. They can't be anything else. Any number except -3 or 6 is going to give us something that isn't 0. Well, here's the answer, and I'll tell you a little bit more about it. Oh, wait a minute now. Can't do that. Well, I've painted myself into a corner. I don't know what something's wrong with what I'm seeing here. It'll be negative there. It's got to go through. Positive number. I can't make it happen. I come up and down here, I've got to go through this point to get up here, right? Then I got to go down here, and I could go down here and just touch that 6 and turn around. But that's not what happened. I got to turn this camera off and figure out what's wrong. It should be turning around at 3, -3. But I can't do that if I've done everything else right. Okay, I was careless when I said this is plus 2268. It's clearly not positive. We have a positive here, and a negative here, right? Right there in front of me. I wrote that down wrong. Now you understand, I honestly made that mistake, but it would have been a good mistake to pretend to make. Because it illustrates that the graph isn't going to match. Okay? I can't go through these 3 points and have this and this unless I have another 0 or turn around at that 6, and I don't get to turn around at that 6. I'll explain why we turn around at -3, but okay. Now we have the point. -2268. Okay, so now here's what happens. We come up to the negative, and we just touch the axis at 3 before we come back down and go through this point. Now, let's see if I can get this working. Then it turns around and goes through this 0. Okay. Now, it helps to understand why it turns around. So the graph turns around here. It looks kind of like a parabola right here, doesn't it? I'll say sort of parabolically. At least in the immediate vicinity of this, looks a whole lot like a parabola. Well, actually, it is a whole lot like a parabola right there. Why is that? Because x plus 3 squared is the graph of the x squared shifted 3 units to the left. It's going to be 0 when x is -3, as we already know. Okay? But close to -3, all this other stuff doesn't change much. So all this other stuff kind of gives you almost a constant vertical stretch in the immediate vicinity here. Now, if you don't understand transformations, you don't understand a word of what I just said, but we got to understand transformations. So you might want to come back to this after you nail transformations. Okay, so all this, if x is, let's say, between negative 2.9 and negative 3.1, these numbers multiply out to something that doesn't change all that much. Okay, like if x is negative 3, that's negative 27, and that's 23. Multiply that out, you get 600 and something. So these numbers stay pretty close to 600 and something. Well, that's just a multiple of this. When you multiply x plus 3 squared by a number, that stretches the graph by that multiple. Okay? It stretches that graph by 600 and something. This is also negative. X equals negative 3, so it stretches and reflects the graph. And it turns out that you do have something very much like a parabola. But as you get away from x equals negative 3, of course, it doesn't stay parabolic. And it goes down faster than a parabola would do. Well, maybe you understand that, maybe you don't, but there's a rule that if some 0 occurs from a squared factor, it acts like x squared graph in that vicinity. It may be reflected. It acts like a vertically stretched x squared graph. If it was cubed here, it would act like a vertically stretched cube graph, which is like this. Okay? And of course, everybody should have a clear picture of what the x cubed graph looks like. So you're going to see that. Okay. Okay, we got the function y equals ax squared plus bx plus c. And we graph this. Well, what we know is find your zeros easily using the quadratic formula. There might not be any zeros because this b squared minus 4ac might be negative, and the square root of a negative is not a real number. No number you can square, you get a negative. And your axis of symmetry is x equals negative b over 2a. Notice, you don't have to memorize two equations. You already know this one. If you know this one, you can ignore the plus or minus square root, and that gives you the axis of symmetry. Okay? Negative b is halfway between negative b plus the square root and negative b minus the square root. Those are your zeros. Your axis of symmetry has to be halfway between the zeros. And the vertex is on the axis of symmetry. So a typical graph might look like this. Axis of symmetry halfway between the zeros always. Even if you don't have zeros, the axis of symmetry is halfway between the complex zeros, if you wish, or just it occurs at negative b over 2a, whether this quantity inside the radical, which is called the discriminant, is positive or negative. Okay, there's the picture. So your parabola might be upside down or right side up. I'll draw it upside down. And here's your vertex. So find the zeros, the axis of symmetry, and the vertex of this. And let me stop. Let me put something else. Okay. Your numbers will be better. Try that one. Okay, I didn't record that, but here we go. It's straightforward. The zeros occur when you plug into the quadratic formula. You get -8, -4, and people got that without any trouble. Unless I made a mistake with the sign or some of the arithmetic. But that's the correct result, and you can check that. Okay. And the axis of symmetry is that x equals negative b over 2a. B is 12, a is 1. That gives you negative 12 over 2, which is negative 6. So we have a picture. We have zeros at -8 and -4. And our axis of symmetry is x equals -6. Now we could use the long run behavior. Okay, the long run behavior, x squared for a big x is way bigger than 12x. Okay, as long as x is bigger than 12, x times x is going to be bigger than 12 times x. Okay, so long run behavior goes up this way and also for negative x. You can check that out. So you know that the graph is going to look something like this. What you don't know is how wide or narrow it is. Does it come down like this, way down here, or does it come down kind of flat, doesn't go a little much below the x-axis? Well, another thing we can do, get a pretty good picture of where this thing is without actually calculating the vertex, although we do want to calculate it, is we get the y-intercept. And the y-intercept, you let x equal 0, you get 32, right? Okay, well, we're putting 32 here. 32 on the y-axis is about as big as 8 on the x-axis, so we can do that. And now, if we want to draw a parabola, we've got to draw one that's pretty shallow there. So the vertex is probably going to be about here. We've got to calculate the y coordinates so we know what the coordinates are. So how do you calculate the y coordinate of the vertex? We haven't already done it. The y coordinate of the vertex, because you know the x coordinate of the vertex is x equals -6, right? You get the y coordinate very easily. So see what you can do about that. See if you get that before I do it for you. So again, if you know the x coordinate of a point, I tell you x equals 5, are you going to be able to tell me what the y value is? Yeah, you're going to take 5 and you're going to plug it in there. You're going to get what, 25 and 60 and 32, okay? Which is 92 and 25, 170. Okay. Now, what do you know about the vertex? It's on the axis of symmetry, and the x coordinate is -6, right? If x equals -6, y equals -6 squared plus 12 times -6 plus 32, which is 36 minus 72 plus 32, which is -2. No, that's -4. Okay. That's all there is to it. You just have to make the connection that since it's on the axis of symmetry, you know the x coordinate of the vertex, and now you can find the y coordinates, and now your vertex is -6, -4. Okay. Now this means you can get the graph of this function by horizontally shifting at -6 units, horizontally shifting the x squared graph, -6 units in the, well, in the x direction, the horizontal shift, and -4 units in the y direction. Now you can use what you know about transformations, or what you should know about transformations, hopefully will a little better after you complete this section. Now quickly, this section is not due until next Tuesday, and that's to give you time to review, because there's going to be a test next week, okay? There's going to be it's not going to be a full credit test. You get one of those after break, okay? It's going to be significant credit, probably 15% of your credit. So you can't blow it off, right? You got to do well in the quiz. It's really kind of a big quiz or a little test. I'll give you more information on it Thursday. Probably send you out some sample problems, especially if somebody emails me to remind me. I've got a big project going on, and the attention is, that's my problem, not yours. You hopefully will not make it yours. If somebody emails me, though, that'll prompt me to do that, okay? Because I might forget. And if not, I'll have it for Thursday anyway. Fair enough? Okay.